Okay guys, today we are going to make a temperature distribution in a plate. So we have 2D heat conductor. As we can see, it will be a copper with the modified thermal conductivity of 401 watt per metal Kelvin. And this is the temperature, and this is the temperature for each, and this is the dimensions for the design. Okay, let's we start it with the workbench. Okay, the first thing that we have to do, we have to choose fluid flow Fluent here. And then we will use design modeler for the geometry. So right click and then click the new design modeler. Because it also provides us with the space claim for the design modeling tools. Okay. We're going to set up the units first into the matter because it's matter basically. And then we have to use the grid show in 2D and snap. We have to check, oh, it's 5 meters. I don't think we need some minors, which is 1 meters, 1 meters. So it's already 5 meters only. This is 5 meters. And we are going to draw it with the line. It's supposed to be 10 at below and then 20 with the vertical line. Okay, people can use also dimension to make it 20 here and also here. Okay, and then we have to concept it and surface from sketches. We are going to use control button to click all of the 4 sketches, all of the 4 lines, and then we are forming one sketch because this is sketch actually. Then we have to generate it. We have done, and then we just need to close it. And then we are going to the meshing. At this meshing button, we are going to set up the boundary conditions, which is the left side, which is there is another right side, and then bottom side, and then the top side. And we are also going to mesh it up with the automatic mesh generator. And then we just need to generate it at the home. Yeah, we have done it. And then we have to set up the boundary condition. We need to choose this one to select the edge. And then right click, name selection, it's bottom side. And this is the right side. and this is the left side. Oops, we don't need this, just delete it. And then the left side, and this is the top side. Then we are also need to make it clear about this one. We are using the face one to select the face. Then we will set it up as a copper face. Okay, this is our boundary conditions. Okay, we have to generate it first before we close it. Then we can close it. And if it is still yellow, we need to right click and update it. We just need to wait for a second. It takes time actually, and then we have the green one, and then we need to do this setup with double precisions, and then okay. And then we are going to use the steady. Steady state means that there is no changing from time to time because it's already in steady. In and out is the same. It's steady. But the transient means that what is happening in the first second and the second and the second second and then the third second and then the fourth second and then in what it will be after 1 minute, what it will be after 2 minutes. You will use the transient rather than steady. Steady is only one picture rather than more than 100 picture. We can use steady as a one picture, as a one result only, rather than transient. And this is not really essential. We can do it with density base or pressure base, but we are doing it with the pressure base, absolute and planar. We are going to check the energy equation, and then we just left everything, it's already on. And then we are going to go to the material. For solid, we choose this aluminum because we are going to change it into the copper by looking up the Fluent database. And then we are going to use solid, and this is copper. Okay, we just need to copy and close. And then because we are going to use the 401 at this time of simulation, we are going to set it up, the thermal conductivity 401. This is all copper. We click change, then close. And then what else? We are going to change this because this one is not supposed to be fluid, but it must be solid copper here. So we just need to click it on, and then is it this one? Yeah, it is supposed to be solid. Okay, and then it's supposed to be copper. Then we can click OK. After setting it up, we have to setting it this one temperature, this one temperature, this one temperature, and this one temperature by looking up with our boundary conditions, starting with the bottom side. Bottom side should be set in its temperature, which is it's supposed to be 100 Celsius, which is 373 Kelvin. And then we have to change the material name with the copper. Okay. This is already thermal. This is temperature. This is left side, so it's 100 Celsius. Then the right side to copper, and then temperature. This is right side, 73, 100 Celsius. Then this is the hot side, which is the top side. And then we have to change it up again with 473. 473. Then this one should be copper. Okay, we have just set it up. We can choose our methods, but I think it would be the ordinary one. We can choose the first order or second order, it would be the same. I think it wouldn't be much difference. This is also the same, controls and everything. Before we do the simulation, actually ANSYS need us to do the initialization, because we want to make everything here in 100 Celsius rather than 200 Celsius. We have to make it from the left or right or bottom, because it's 100 Celsius or 373 Kelvin. So we can compute it either from bottom or right or left. Okay, so that we can see it through the graphics, the contours. And here we got the temperature contours. Then we need to display it up, and then we got, oh, I forgot to initialize it. We have to initialize it first, like this. Okay, and then we can just display it. Oh, what's wrong? I think everything is already right. And then we just need to check our contour. Oh, it's pressure. It's supposed to be in temperature. Ta-da! And then the temperature of contour all is 373 Kelvin. So it's supposed to be 373 in the initialization. And then we got it from the initialization, and we can run it right now. We are using, yeah, this is okay. We don't need use this one, that sampling for statistic, or you can use this one. You can check this or not. If this is your research, you should check this out. Then the number of iterations should be 1000. Okay, we need to calculate it up right now. Boom. Okay, it's done. We can see the contours right now. And this is our result. Okay guys, thank you for watching. God bless you. See you next time. Don't forget to save your files.